Today in the morning sessions, we are discussing about the classification and we are discussing one of the methods, and that is decision tree for classification. We have seen what is a decision tree, and we are talking about the splitting attribute. So how to select the splitting attribute? Okay. So for that purpose, we have to calculate the measure of goodness, and for which we need two different methods to calculate the measure of goodness. One is information gain, and another one is the Gini index. Information gain we have completed. Now we'll talk about the Gini index. Like Gini index is just opposite of information gain. We are taking those attributes which are having higher information gain for splitting. But in the Gini index, we are calculating the measurement of diversity, and those attributes has been selected which are having the less Gini index value. Okay, so those who are having the less value will be selected first, and depending upon the hierarchy or the sorted one, we'll select the next attribute and so on. Okay. So in the Gini index, all attributes are assumed continuous value. Continuous value means one value is usually linked with another value. Then we called as a continuous value. This is discrete values are those which are depending upon a proper interval, and the continuous values are those in which one value is linked with some other value in certain order. Okay, so it's assumed that there is several possible split value of each attribute. So usually Gini index is applied to those attributes which are containing so much partitions or so many different types of variability. Okay. So it can also be used for categorical data as well. So how to calculate the Gini index? To calculate the Gini index, we are using this formula, and where the Pj is your relative frequency of J in T. It means how many times J will be there in a complete data set. Okay. So suppose T contains the example from T contains example from n classes. So you have n number of classes where T contains different examples. Like T is your complete data set T. So to calculate the Gini index, the formula is 1 minus summation of J equals to 1 to n Pj whole square. So we are taking the square of relative frequency, how many times a particular you can say particular values appear into the attribute. We take the square of that, and then we'll take the summation of all these values. Then it will give me a Gini index value. Okay. Suppose if the data set is split into two subsets like T1 and T2 with size N1 and N2, then this formula will be revised based upon the partitions of the data set. Then T split will be calculated as N1 by N, Gini T1, and N2 by N, Gini T2. Okay. So this will give you a split of Gini index. Okay. So after splitting the attribute, this can be used. This is based upon the partition of the data sets. Let's see the example here. Suppose we have total 14 different rows in the training set, and this is a very same example. If you want to look at back at that example, so this is so somehow the training set is given here. So this is the weather data set. So in actually here the 14 rows are there, and we have two class label, yes or no. So this is related to whether to play golf or not, and which is dependent upon 4 different attributes. And last, the class label is only binary classes, either play or not play. Okay, and these are the 4 attributes which has to be considered for taking these decisions. So we have to build the trees by using these 4 attributes, and at the leaf node we'll get the class label. Okay, yes or no. Okay, so to calculate the Gini index of complete outlook attribute, so this is the complete outlook attribute of the training set. in which we have to take the summation of Pj, okay, and the whole square of that. So Pj is two parts of j, one is yes and one is no. So yes values are total 9 values. So we take 9 divided by 14 and take the whole square, and then minus 5 divided by 14 to the whole square. So this will give me a Gini index of the outlook value. Okay. And then this outlook is further divided into 3 different parts. And these different parts are further divided into yes and no. So the values present in 3 parts is either yes or no. So this is the Gini index of complete attribute. Now we'll calculate the Gini index value of splitting after splitting of the outlook value. Okay, so that this split takes part in three different partitions. And what are these partitions? The one is sunny, then rainy, and one is overcast. Okay, so the first value is sunny, which contains 5 different rows, and in that 5 different rows will have 3 times yes and 2 times no. Okay, so first we need to calculate the Gini index of this partition. To calculate the Gini index, we'll take 1 minus 3 divided by 5, because 5 are the rows which are taken in sunny under the sunny value. Then 2 divided by 5 whole square. So this will give me a Gini index value for sunny. Now we'll take a partition of that, because the partition formula says n1 by n. So n1 is 5 rows and the total n contains 14 rows. So we multiplied it by 5 by 14. Okay. So similarly, to calculate the Gini index for second partition, and second partition is your overcast partition. So we'll take 1 minus 1 by 5 whole square. So it somehow will give me a single class, because it's only contain a yes class. So 1 minus 1, that will be 0, and it will multiply by 4 divided by 14, because 4 rows are there which lie under the output category. Okay. So the next one is the third value of outlook is, third partition is rainy, which also contain 5 different values, where 3 times yes and 2 times no is there. So we'll first calculate the Gini index, then we multiply it with the partition. And the partition is here the same. 5 rows are present into the rainy, divided by 14. And this is same formula, 1 minus summation of Pj whole square. Okay, so by this formula we can calculate it. So in this way, we are calculating the Gini index before splitting and after splitting. So best splitter is determined as the attribute which has the smallest Gini value. So similarly, we can calculate the Gini index value for other attributes like weather, temperature, and all these. And those who are having the minimum Gini index value, that will be selected first at the very first level of the decision tree. So any of the measures can be used in selecting the splitting attribute. Now the one more thing that is remaining is the splitting criteria. Splitting criteria, you have seen when you develop the tree, you have taken certain conditions. On the basis of that condition, your data is being partitioned into left side and the right side. Okay. So considering this condition is a very important part, and this condition is called splitting criteria, because based upon this criteria, we are dividing the data into 2 disjoint subsets. Okay. So for any continuous or numerical value, what we need to do, we just first arrange or sort the data. We sort the data. Suppose you are having values in different order, you just need to sort it and you take the mean of that. If you're taking the mean, it will give you a mid value, which are dividing the data into left side or the right side, that could be chosen. And this is our split point. Okay. So split point, if you have numerical attributes, selection of the split point is very easy. You just sort the data and choose the midpoint. Okay. But if your data is not numerical, then in that condition, you cannot exactly choose the middle one. Okay. So first, we'll see uh, what things are used. These are used as a class histograms are used for numerical attribute. So suppose this is your training data set like age, salary, and these are the classes. So it's also binary class B and G. These are the two classes. Okay. So now you have to select the splitting criteria. So what you need to do, you just need to sort this data and take a midpoint. So uh, it will come out to be salary is less than equal to 70. So we can draw it in a class histogram manner where you can find the left side values and the right side value, and we have two class labels. So we have chosen the splitting criteria will be written here and left right written at the bottom, and we have two class label B and G. Now we can categorize two values at the left side and two values on the left side of G class. Then at the right class, we'll have 0 values at B class label and 2 values at G class label. So all the 6 values can be categorized in such a manner when you are having the numerical attribute. Class histograms are used. And then if we talk about the categorical attributes, so we'll take the subsets of the possible subsets of these values. Okay, so to generate the possible subset, we use the count matrix. In place of class histogram, we use count matrix. Okay, so the count matrix stores the class distribution of each value of a categorical attribute. Okay, so what we are having two classes, high and low. And there is one attribute who is having, the name of attribute is not given here, but it's having 3 different values, family, sport, and truck. So because all the values are different in the categorical attributes, so we generate a count matrix that will show two classes, high and low are the class labels, and these are the 3 values which is subset of this attribute. Okay, so these are the subset, family, sport, and track. So those who are having high value in family, two instances are having high value in family, one instance have low value. Similarly, in sports, we have 2 high value and 0 low value, and in truck, 0 high value and 1 low value. So in this way, we can define our splitting criteria. So obviously for this attribute, the splitting criteria is 3. That is family, sports, and truck. Then we have different type of tree constructions algorithm where the information gains are used. That is ID3, interactive decommitomizer 3, and then C4.5, C5, J48. Guinea index is used by Sprint, click like this algorithm. And we have other constructions algorithm like public, rainforest, and board. So actually, the discussion on these algorithms beyond the scope of your subject area, because we are taking an overview in this subject, and we need not to discuss in detail what are these algorithms. If somebody want to study, you can study. Okay, so I will not continue your lecture further because I will start new topic tomorrow morning, and I have a meeting at 3:30.